We're going to go right into checking our homework today. It's page 477, 1 and 2, and we're going to go over question number 2. It says a 1,050 kilogram car at an intersection has a velocity of 2.65 meters per second to the north. It hits the rear of a stationary truck. Their bumpers lock together. That means that the two vehicles after the collision go off as one object. The velocity of the car-truck system immediately after is 0.78 meters per second. What's the mass of the truck? So picture this. Okay, you got a car that's moving at an intersection. You got a truck that's sitting there. They hit. Okay, they collide, and then they go off as one object. That's a conservation of momentum problem, right? Because it's a collision. Now, technically, I could analyze just the car and use impulse because it's going to lose momentum, right? Or I could analyze just the truck and use impulse because it's going to gain momentum. But it makes the most sense, I think, in this question to analyze the system and use conservation of momentum. As long as I have an isolated system, it's okay to use the law of conservation of momentum. Momentum will always stay the same in an isolated system. What do I mean by that, by the way, an isolated system? Yep. Yeah, no forces from the outside, no external forces, nothing causing it to gain momentum or lose momentum. All right, let's write down some givens here. We're going to call object number 1 the 1,050 kilogram car. So call that M1. We're going to say that something is 2.65 meters per second. We're going to say that something is 0.78 meters per second. And we're going to say that we're looking for the mass of the truck, object number 2. Tell me what the 2.65 is. 1,050 kilogram car at an intersection has a velocity of 2.65 meters per second. Is that V1 or V2? Object 1 or object 2? The car or the truck, Dom? That's the car. So we're going to call it V1. But is it V1I or is it V1F? V1I or V1F? It's going to be V1I, the initial velocity of object number 1. Good. What's the 0.78 meters per second? Peyton? V1F is, you know what, be careful. I don't want to call it V1F. I'm going to call it just VF. Anybody tell me why I didn't put the subscript for the number of car it is? Christian? Right. It's object number 1 and object number 2. Saying V1F is not wrong. Saying V2F is also not wrong because it's both of them. Since it's both of them, I'm just going to call it VF. Looking for M2, the mass of the truck here. All right. Anything else I have if I read between the lines here? There's one word that tells me something else. That's your hint. One word. What is it? Stationary. Yeah. So something is 0 meters per second, right? What is 0 meters per second? Is it V1 or is it V2? 1 or 2? Matt? It's going to be object number 2, the truck. Is it going to be V2I or is it going to be V2F? Initial or final? Caitlin? Good. V2I is 0 meters per second. The truck is not moving before it's hit. Right? It's the guy in the truck is the law-abiding citizen who's sitting at the stop sign waiting, and then the other guy, the car, is the guy that runs into the back of him at a speed of 2.65 meters per second. All right. PI is equal to PF here. Let's say M1 V1I plus M2 V2I. What's MV stand for? MV is momentum, right? How many objects do we have before this collision takes place? There's a car and there's a truck. And you guys have made it to physics 30, apparently by not being able to count to 2 objects. 2 objects, 2 momentum terms, M1 V1I, M2 V2I. Now afterwards, what am I going to write? How many objects do I have, Dom, afterwards? 1. So let's just put 1 term in. I don't want to put in the 1, the 2, or I could put in M1, 2, the mass of object 1 and 2 combined, but I don't want to do that because the subscripts could get a little cumbersome after a while and you start putting too many of them in. Okay, let's see what we can find here. M1 is 1,050. V1I is 2.65. This is 0, so I'll just cross it off, right? M2 is, we don't know, but M2 times 0 is 0, regardless of what the value of M2 is. We don't know what M is, the combined mass is, but we know what VF is, 0.78. So let's get M there. Let's say 1,050 times 2.65. Divide that by 0.78. Gives me a mass of 3567.307. But that's not the answer that's given to us in the book. What have I just found? What have I just found, Haley? Yeah, the mass of the truck and the car combined. What am I looking for? Right. So if you've got the combined mass and you want to find the mass of the truck, let's say the mass of the truck is going to be 3567.307 kilograms. Subtract the mass of the car, 1,050. And when we do that, it should work out to be 2.5 times 10 to the 3. Good. All right. Let's do another example then, okay? Page 478 this time. It says, a basketball player in a wheelchair, player A, have a combined mass of 58 kilograms. She moves at 0.6 meters per second to the east, pushes off a stationary player, player B, while jockeying for a position near the basket. Player A ends up moving 0.2 to the west. Combined mass of B in her wheelchair is 85 kilograms. What's player B's velocity immediately after the interaction? It's a collision, right? It's a conservation of momentum problem. Now, I could technically look at the objects individually, the object A, the person A, and use impulse, or analyze person B individually and use impulse, because each of those people experience a change in momentum. But it makes sense, I think, in this context to solve the system. It's an isolated system. There's no external forces that we know of, so we can use conservation of momentum to solve that. All right, what should I circle in red here? What should I circle in red as we go through this? Yep. Yeah, the east and the west thing, to remind me that something's negative and something's positive. Have you noticed that every question we've done this year, we talk for 30 seconds or a minute about the question before we actually write down any givens? That's what you should do, right? Think about the question before you write down givens. We've talked about this a million times already. Givens are important, but thinking about the question is important too. And the danger of writing down givens as soon as you see them is you go straight to trying to solve it without thinking about the question. All right, so what do we have now that we've given it some thought? I'm going to say M1 is 58 kilograms. I don't want to call it MA. You can if you want. But if I start introducing letters for the objects, then I'm going to have like MA, VA, I, and the letters are going to just confuse me. I'm a math science guy, right? I don't like letters. Let's put numbers in there. M1, V1I. Okay, although letters are fine if it works for you. M2 is 85 kilograms. Something is 0.60 meters per second. Something is 0.20 meters per second, actually negative because it's to the west. Not going to forget that because I've got it circled. Tell me what the 0.6 is. What's the 0.6 meters per second? Ilma, is that V1 or V2? Good, it's V1. Is it V1 initial or V1 final? Sorry? Yeah, it's the initial velocity of object number 1. How fast the first person in the wheelchair is moving. What about this negative 0.2? Player A ends up moving at 0.2 meters per second to the west. Elena, is that V1 or is that V2? player A ends up moving at 0.2 meters per second to the west. So after they collide, player A is moving this fast. V1 or V2? Object number 1 or object number 2? Good. Yeah, V1. V1I or V1F? Yeah? F. It's the final velocity of that object, right? We're looking for V2F, right? The final velocity of player 2. Anything else we have? If we read between the lines, Greg? We do have the total mass of the system, yeah, although, well, actually, we don't have it, although we can find it really easily by adding them up. Yeah, we'll worry about that when we actually go to crunch numbers, though, if we need to do that. V2I is equal to 0 meters per second, right? It says pushes off a stationary player, player B. It's kind of tricky. It is. It's kind of tricky to come up with the givens for these, especially with all those subscripts, right? V1I, V2F, and so on. Fair. Let's set it up now. Pi equals Pf. There's two objects before, so let's say M1 V1I plus M2 V2I, and MV for every object. And this time, unlike the last example we did, and unlike the last set of practice problems we did, they don't stick together. They bounce off of each other. So that means that we're going to have two objects afterwards as well. These masses don't cancel. But is there ever a time when they would cancel? Is there ever a time when I could cross off mass from every single term there? Doesn't happen very often, but there is a time. When would it be? Yes, if all the masses are the same. M1 is 58, V1I is 0.6. V2I is 0, so I'm just going to cross that off. M1 is 58 again. V1F is negative 0.20. M2 is 85. V2F is what we're looking for. 58 times 0.6. So we're going to add 58 times 0.2. Do you guys see why I'm adding that? It's a negative on the right-hand side, right? So I got to take it to the left by adding. Let's divide that by 85. If the algebra there didn't make sense to you, just let me know and we'll go through it in more detail, okay? We end up getting 0.55 meters per second. Is that good? How is this question similar to the ones that we did yesterday? Well, there's a collision, conservation of momentum. Each individual object has an impulse, but the system doesn't. The total momentum remains the same. There's two objects before the collision, yesterday and today. How is it different? The only difference between yesterday's questions and today's question is when they collide, they don't stick together. So instead of having one object, MVF, after the collision, now we have two, M1 V1F plus M2 V2F. That doesn't make it harder. That just makes it slightly longer, that's all. Okay. What I want you to work on now and finish up for homework if you don't finish it in class are the practice problems that go with those on page 478. These ones.